Okay guys, today's lesson is the big one, the quadratic formula, one of the most famous equations in all of mathematics. Many of you have probably seen it before, maybe even worked with it. If you have not, that is okay. I'm going to treat this as if you've never seen it before, although last class you have seen some of it, the discriminant. So it says at the top, the quadratic formula can be used to solve for x, any equation in the form ax squared plus bx plus c equals 0. So what do we have there? We have a quadratic equation in standard form set equal to 0, which means y is 0, and we're solving for x. So what are we finding? The x-intercepts, or the roots. Okay, so the solution to ax squared plus bx plus c equals 0 is x equals all of this. And this is what's known as the quadratic formula. So it's a little daunting. Like I said last time, it's really not that bad. We're going to replace all those letters with numbers and just work some arithmetic. You've already done the discriminant last class, b squared minus 4ac. So that's most of it. We'll just do a couple more things and we'll be finding the x-intercepts of any quadratic equation we want. Let's jump into it. So example 1. Example 1 says solve for x. 2x squared plus 5x minus 33 equals 0. Now, if this wasn't a notes packet or notes on the quadratic formula, you might think of other ways to solve for x. We might think, I wonder if I could factor that. This is not the pen color I want. I wonder if I can factor that, what we did last time when a is not equal to 1. Let's see. I could try factoring 2x squared plus 5x minus 33 by, the first two numbers here would be 2x and x. 33, what multiplies to 33? 11 and 3. Oh, well, what if I put a 3 here and an 11 here? And I want to get a positive, so if I put a minus here and a plus here, and x equals 3 is one of the solutions, and what multiplies to 2? What multiplies by 2 that makes 11? 5.5, so negative 5.5. So it is factorable, and I was able to find the solutions to that. But not all quadratic equations are factorable. So factoring is a bit limited. It doesn't always work. And that's what the quadratic formula is for. So we're going to see if those two solutions I just found are indeed matched by the quadratic formula. So let's jump back into the quadratic formula. We didn't want to factor this, or we didn't realize that we could factor that. We're going to use the formula from the top. And like last class with the discriminant, I said it's sometimes helpful to list a, b, and c right off the bat, so that's what we're going to do. A is 2, b is 5, and c is negative 33. If it has a minus in front of it, don't forget that gets attached to the number or the variable term. All right, we're going to plug those values into the quadratic formula, which says x equals the opposite of b. I'll slide it down so you can see it again. At the top, highlighted. The opposite of b plus or minus the square root of b squared minus 4 times a times c, the discriminant, if you remember from last class. All over. Make sure you get that division bar all the way across. 2 times a, and a is 2. And there we have it. We have no more letters. It's just arithmetic to accomplish. So we'll break this down piece by piece. We'll use the appropriate order of operations, and here we go. I'm going to take care of the top first. You could work either the top or the bottom of a fraction. The bottom's pretty easy. In fact, I could just call that 4 right now if I wanted. So actually, I took care of the bottom first. But back to the top. I have to do what's under the radical. The radical's grouping all that information, the discriminant, together. So I have to take care of that before I do any adding or subtracting. So I'm going to just write negative 5 plus or minus the square root of. Well, 5 squared is 25 minus 4 times 2 times negative 33. Well, 4 times 2 is a positive 8, and 8 times negative 33 is going to be a negative something. Anybody know what 8 times 33 is? 264 says my calculator. All right, so but that's a minus because I did 4 times 2 times negative. So that's going to be a minus 264. And that's good because if I had subtracted 264 from 25, I would have got a negative number, and that would have told me that there's no x-intercepts because we can't take the square root of a negative number. But I've already done this one with factoring, and I'm pretty sure there's 2 x-intercepts, right? So when we do have a minus of a minus, we really have addition. So I'm going to finish up what's under the radical here. Negative 5 plus or minus the square root of 25 plus 64 is 289. Now for some of you that may be jumping out, 289 is a perfect square. I'm going to rewrite over 4. So I'll continue my work down here to the left, below what I had before. So the square root of 289, like I said, perfect square. Anyone know what it is? 17. And now we're to a pretty simple point. We have negative 5 plus or minus 17 over 4. And that plus or minus basically breaks this little expression into 2 pieces. So we're going to both add 17 to negative 5 and divide by 4. And I'm going to separate with a comma the other expression. We're going to subtract 17 from negative 5 and divide by 4. And this is how we get 2 solutions. So negative 5 plus 17 brings us up to what? 12, positive 12 over 4. And negative 5 minus 17 is negative 22 over 4. 12 divided by 4 is 3. And negative 22 divided by 4 is negative 5.5. And you can see that the quadratic formula does take some time, especially when you work through it piece by piece, but it does produce the solutions. But I wouldn't have used this if I was working this problem out and we weren't working on the quadratic formula. I definitely would have factored to solve, but you can see that it does give us the solutions. All right, let's try the next one. I'm going to move a little faster through this. So irrational solutions, or approximate solutions, it says here, which means that this one is not going to be factorable. We are going to have to use the quadratic formula. So x squared plus 3x plus 1. Let's just quickly try to factor it. X squared plus 3x plus 1. X and x, 2 numbers that multiply to 1 and add to 3. Ain't happening, right? The only things that multiply to 1 are negative 1 and negative 1, or positive 1 and positive 1, and neither one of those add to 3. So we can't use factoring in this case, which tells us that we're going to have solutions that aren't integers or whole numbers. Let's go to the quadratic formula. A is 1, B is 3, C is 1. Quadratic formula says the opposite of B, x equals the opposite of B plus or minus the square root of b squared, I'm going to call that 9, 3 squared is 9, minus 4 times a times c, over 2 times a, which is 2 times 1, which is 2. So I did a few things in my head there, right? Let's go to the radical. Negative 3 plus or minus the square root of 9 minus 4 times 1 is 9 minus 4, and that's 5. So pretty good progress. Real quick. Didn't take long. I'm going to leave that square root of 5 for now, and I'm going to rewrite negative 3 plus the square root of 5. over 2, comma negative 3 minus the square root of 5 over 2. I haven't done any rounding up to this point. Okay, so I'm going to go to my calculator, and the square root of 5 is 2.24, so that's negative 3 plus 2.24 over 2, and negative 3 minus 2.24 over 2. And that's going to be 0.38 and negative 2.62. All right, let's take a quick peek at, I did the graphs, I forgot to. Okay, and we are back. Example 3. Example 3 is 4x squared plus 12x plus 9 equals 0. It does say this will produce one solution, so that must mean that the discriminant's going to be 0. Let's find out. A in this case is 4. B is 12, and C is 9. The opposite of B is negative 12, plus or minus the square root of 12 squared is 144, minus 4 times A times C, and 4 times 4 times 9 is also 144, so I can see that coming. 2 times A in the denominator is 2 times 4, which is 8. So we're going to have negative 12 plus or minus the square root of 0 over 8. And here's why when the discriminant is 0, there's only one solution. Because the square root of 0 is 0, and we have negative 12 plus 0 over 8, and negative 12 minus 0 over 8. Like I said last time, adding 0 and subtracting 0 are the same thing. So negative 12 over 8 and negative 12 over 8. It's only negative 12 over 8. So that is negative 1.5. That is the x-intercept. And let's check on the graph of this one. Okay. Oops. Graph of the first one. One more to do. Example 4. This one has no solution. That must mean the discriminant is negative. Let's find out. A value is 2. B value is 5. C value is 4. The quadratic formula says x equals the opposite of b plus or minus the square root of b squared. 5 squared is 25 minus 4 times 2 times 4. 4 times a times c all over 2 times a, and 2 times 2 is 4. Negative 5 plus or minus the square root of 25 minus 4 times 2 is 8 times 4 is 32. Right there we have a problem. I don't even have to continue. This is a negative number, and the square root of a negative number is undefined in the real number system. And so because of that, we can just stop and say that there is, we can stop and say there is no solution. And I will show you that one as well. Your turn. Here's the guided practice. I will attach this to the lesson in Google Classroom. You've got 6 problems to work on. Oh, you got more than that. You got 8. I'll tell you what. Let's just do A, B, and and C and D. There's two A and B's. Let's do the first two A and B's and C and D. So don't worry about these. Do these and these. And don't worry about these either. Alright, good luck guys. Pause, rewind the video if you need any assistance. I'll give you the shortened version of this during class today. There's the graph of the first one. There's your -5.5 and 3, and you can see that's from the equation 2x squared plus 5x minus 33. We did get those two x-intercepts. And this one we just worked on. -0.38 and -2.62. And that is x squared plus 3x plus 1. So those are the two things I said, I believe. There it is. 4x squared plus 12x plus 9 has an x-intercept at -1.5, 0. Here's the graph of that last one. And it opens up with no x-intercepts. It's above the x-axis with its vertex. And I did highlight the y-intercept there just to remind you that that C value is still the y-intercept, even though we've been working on finding x-intercepts. Don't forget that the y-intercept is there as well. Okay, so that brings us to